morning, students. Today our topic is applications of Newton's law. Free body diagram, FBD. The free body diagram is an important role in applications of Newton's law because of it is a pictorial representation of forces acting on the body. It is very easy to analyze the motion of the object and how many forces act on the object in base of Newton's law of motion. It is a 3 steps are very important in free body diagram. First one is identify the forces. How many forces act on the objects? The forces, number of forces identified. Second step is the object just will be measured, consider just a point. And third one is draw the vector representing of forces acting on the object. So 3 steps are very important in to develop the free body diagram. Analyzing the motion of force, motion of the object and how many forces act on the object. Particularly identify the forces. It is a very important free body diagram. For example, consider one object. The mass of object is m. In a surface, the place around on surface, the object is at rest. You know, well, simply said that there is no force, but the 2 forces act on the object. Here, 2 forces act on the object. First one is gravitational force. I mean weight of the object, W is equal to mg. And next one is normal force, N. So the 2 forces act on the objects. At the same time, a very important topic here, mg and normal is not action-reaction force. It's different in nature. I will discuss a last topic. But first one, free body diagram. The free body diagram means I want to first of all identify the forces. How we can to identify the forces on the object. So this is mg is a gravitational downward force and normal force is a upward force. Mg is always acting downward force. It indicates weight of the object. Normal force is always act on perpendicular to the surface. It is very important. If just imagine I am your single point, the normal force act in perpendicular to the surface. If just what happen, if inclined in angle, my weight is act in downward direction, but normal act in perpendicular to the surface. Just inclined in this angle, the normal force act in this direction, but weight which means a downward force, gravitational force act in always downward force. But the normal is always perpendicular to the surface. What is the net force? Net force W, mg minus. So this is a very important. First one is the divided coordinate also. This x-axis, y dash. This is positive. N is equal to N is opposite to the direction of mg. So minus mg which is equal to 0. So N is equal to mg. Base of coordinates. You know well coordinate x coordinate basis. This is the first one example of free body diagram. To draw the free body diagram, just simple, the object is represent just point. I want to draw the free body diagram. Free body diagram means consider first step is identify the forces. Second one is the object just represents point. So this mass is considered one point. In downward force mg, normal force n. This is n. Just the object consider point. The mass of the object is not considered here in free body diagram. If horse, elephant, aeroplane, helicopter, human being, anyone just consider one single represents a point. This is downward force mg, and n is normal force in upward direction. Normal force always acts in perpendicular to the surface. So very, very, very important one. And next one, what happened? when object is just hanging in one surface. Consider m mass of object in through hanging in one wire or anyone. And next one, and downward force is equal to mg. And normal force is here tension. There is a tension force. A tension T is equal to mg. So T is equal to mg. Now here is not called normal force. This is tension. Because and next one is just to take it on a example. One object, another one object m. This is mass m1, this is mass m2. Just draw the free body diagram of this. What's a free body diagram of this? The two objects placed on the surface of table or anyone. So m1 and m2. What is the first of all? I want to draw the free body diagram of in block m1. F B B of m1. Consider m1 is a one single point. Just in our convenient m1. What is this? Downward force. The weight of the object is m1g, and normal force act in this n, normal force. So where is the normal force act? Where it comes from this normal force? C is very important. The normal force exerts. We mean the m1 is a very important. m1 placed on m2, the surface of m2. This surface should act in normal force. So that is n, normal force n1. Normal force n1 in our convenient. And next one, this is, you know well, n1 is equal to m1g. n1g. And second one is, what is the FBD diagram of m2 mass? Mass of m2. You know well the weight of the object m2g. m2g. In the surface is very important. The surface should act on normal force. This is just will be taken this n2. Normal force n2. Here you know well the second, the first object on the object of m2. Is there this object A, this object B. A placed on B. Very important. Just imagine A is placed B, m2. M1 is placed on m2. In m1 object, the normal force is n1. Normal force is n1. This n1 force is according to third law of motion. The first object exerts force on m2 surface. So the n1 is should act in downward force of n1. n1. So here, what does the net force act on the object is? Normal force, I want to calculate this. Normal force n2 is equal to, in downward force is equal to m2g plus n1. Plus n1. So n2 is equal to m2g plus n1 is equal to m1g. So normal force n2 is equal to m1 plus m2 of g. This is net normal force act on the object. Simply draw the diagram is this is m1, this is m2, overall m1 plus m2 of downward force is equal to m1 plus m2 of g. This is normal force n2. Normal force n2. This is free body diagram. Free body diagram of two objects. Just will identify the how many force act on the object, vector represents of forces on the object, and just so we consider one the object, simply consider point point I, which means a point mass. Consider just simple point, represents point. So this is a 3 steps of free body diagram. It's examples of free body diagram. 3 steps. First one is identify the force. Second one, object that just represents point. Third one is draw the vector representing of the forces on the object. It is a very important topic in laws of motion. Second one, next example, 3 objects. If block A, block B and block C. 3 blocks are just placed on the table. Just draw the free body diagram of these blocks. You know well block A, block B, block C. So I want to take in simple A, B, C. The mass is M A. This is mass of MB. This is mass of MC. In our convenient. See, first one. Free body diagram of block A. Just draw the free body diagram of block A. A object. The free body diagram simply in our convenience. Just draw the point mass. Just the weight of the first one is MAG. In normal force is NB. It is a very important. Where it comes from this NB? The second block of surface exerts force on normal to the surface of A. So this is normal force is NB. See, this is object A. This is B block. Downward force, gravitational force is MAG, which means the weight of the object A. MAG act in downward direction is placed on the block of B. The block B exerts force in normal, I mean the vertical direction, normal to the surface NB. NB. Here very important, NB is equal to MAG. MAG in FBD diagram of block A. And next one, FBD diagram of block B is equal to, this is B body, B block. Is placed on surface of block C, already A here. It's very important. Listen. This weight of the object is MBG in downward force. It's a gravitational force. Weight of the object is downward force MBG. What is normal force? Normal force is, listen to me, the block C experience force on B. The block surface of C experience force on B. This is NC, normal force. And another one, the B, listen, the object A, listen, very important, this is normal force NB. This equivalent force of A surface placed on B. So, these NB equal and opposite forces act on B. So, listen, A acts on B surface. So, downward force, another one is NB. Another force is NB is very important. Is a MBG is a gravitational force, NC is a normal force. Block A exerts on the surface of B. Exerts on the surface of B, which means NB is a normal force of block A. Same force, equal and opposite forces exerts by the block B on surface of block C. So the net force NC is equal to NB plus MBG. So NC is equal to, what is NB? NB is equal to MAG. MAG plus MBG. So NC is equal to MA plus MB of G. And next one is block C. Block C. This is block C. Place on the table. What is the downward force? mcg. Normal force is nt. The table surface should experience exert force in normal to the surface. So surface, which means the upward direction normal force experience the table. Upward direction nt. You know well, B block on here. The B block experience NB is a very important. Here NC normal force actor. Equal and opposite forces experience on the surface of C. So downward force is NC. So the net force normal NT is equal to NC plus MCG. So NT is equal to, what is NC? NC is equal to MA plus MB of G. MA plus MB of G plus MCG. So NT equal to MA plus MB plus MC of G. This is net force act on the surfaces through 3 blocks. The net normal force. Net normal force. This is very important examples of free body diagram. Next one example, free body diagram. Consider one object is placed on the surface. Placed on the surface. 2 forces act on the object. First one here, F1. Another one here. This is F2. If 2 forces act on the object, what is the motion of object? What is the resultant net force of the object? Just draw the free body diagram. Very simple. This is a question. 2 forces act on the object. Draw the free body diagram and to find the net force act on the objects. Net force act on the object. Simple. The mass of object is M. What does? Just simply identify. First of all, weight W is equal to mg and know well normal force N. This normal force nothing but the surface exerted on the object. It's a normal force. And this is F1 and this is F2. Just first of all, in this direction, draw the coordinates in our convenient. X, Y. The force act in this direction F1. Suppose this angle is theta. Angle is theta. This force coordinate to make an angle is theta. This force is divided into 2 components. One is F1 cos theta in horizontal direction. This F is goes to this direction and in horizontal parallel to the x-axis to make an angle this. So this is horizontal components. So F1 cos theta. This is F1 sin theta. Same phenomena. Apply this. F1 cos theta. Here this component is F1 sin theta. F1 sin theta. Same phenomena in F2 to make an angle. This is theta and to make this theta. Here the resultant components is F2 divided into 2 components. One horizontal, another one is vertical. Horizontal F2 cos theta. Here this is F2 sin theta. F2 sin theta. I want this divided upward direction force, downward direction force, and right side direction force and left side direction force. Just balance is upward force is equal to downward force. It means you know well upward force means summation of f of y is equal to summation of f of x, which is equal to 0, which means the balanced condition. So f of y is equal to f of x is equal to 0. In our convenience, just I want to take upward force and downward force. What are the upward forces? Upward forces, just calculate this normal force, and next one is F1 sin theta. Normal plus F1 sin theta, which is equal to What are the downward forces? mg plus F2 sin theta. F2 sin theta. This is downward forces. So upward forces is equal to downward forces or condition balance conditions. There is no motion of the object. When object is maintained in rest, just the divided components based on the free body diagram. Based on free body diagram. What is the left side direction and right side direction forces? Right equal to left side. So what is the right side forces? Right side only F1 cos theta is equal to F2 cos theta. And next one is in free body diagram. Draw the free body diagram. Force F1. This is F2. You draw this. Just the surface is inclined angle of theta. What happened? Inclined of angle of theta. Here the surface just inclined in this direction. To make an angle is theta. Now just draw the free body diagram. Free body diagram. Here this is F1 force. This is F2 force. To draw free body diagram of these two forces, very easy one. An inclined plane, angle is theta. This is mass of object is m. Two forces F1. Here another one force is F2. To make an angle is theta. To draw the free body diagram, you know well, this is mass in downwards weight. I mean the downwards gravitational force is weight of the object is acting in this direction. This is mg. This is mg. This net force is divided in two components because it's not a surface, just incline an angle of theta. So this is horizontal, this is vertical component. The angle is theta. You know well, to make an angle is theta in inclined part. So these mg downwards force is divided in two components. One is horizontal, another one is vertical. So this is mg cos theta, and vertical component this is mg sin theta. mg sin theta. You know well, this is F1 is also just inclined. Just I want to take this is x-axis. This is x, y. X-axis. This is y-axis. So F1 is divided in two components. F1 cos theta. This is vertical. F1 sin theta. You know well, to make an angle is theta. Angle of theta. And F2, this is the angle is theta. Is divided in two components. One is F2 cos theta, and another one here. This is F2 make an angle is theta. This is F2 cos theta. This is vertical component F2 sin theta. Vertical component of F2 sin theta. I want to calculate this upward direction force. Upward direction force is equal to downward force, and left force and right side force. Just simple this. This is right side. This is left side. This is upward force. This is downward force. Upward force equal to downward force. What are the upward? See, just one mg is a downward direction force. Is divided in two components, mg cos theta and mg sin theta. The normal force is always acting perpendicular to the surface. This is normal force. Is very important. Now we are divided. Upward force is equal to downward force, In upward forces, what are the upward forces? What are the downward forces? In upward forces, this is upward direction. This is downward direction. This is right side. This is left side. See, upward forces N plus F1 sin theta is equal to downward forces F2 sin theta plus mg cos theta. These are components of upward and downward forces. Another one is components of right side and left side. Right side is equal to left side. In right side is F1 cos theta. F1 cos theta is equal to, in left side, F2 cos theta plus mg sin theta. F2 cos theta plus mg sin theta. This is a free body diagram of given objects. When the two forces act in this direction, to draw the free body diagram first, after you identify the forces, and after you represents the vector represents of forces in a object. After we calculate the net force on the object. It's very easy to calculate net force using free body diagram. It is applications of Newton's law. Next one is one example on book is simple on the table to calculate the forces, which means draw the free body diagram or how many forces act on the object, it means book. It's very important, you know well. Simply said, the mass of object is m and mg is a downward force, the normal force is n. Normal force is n. And next one, here is mg is, and mg and n is not a action reaction forces. It's a very important one. Most of them, all of them are consider this mg and n is a normal and action reaction forces. Here mg and n is not a action reaction forces. Just different in nature, mg and n. The object is lying simply rest position, so mg is balanced with n. It's not possible because of mg is a gravitational force. N is a normal force exerted by the table on the book. So action and reaction force never act in same body. According to Newton's third of motion, action reaction is never interact, which action reaction never act on same body. Must be act in two different bodies. Here mg and n is not a action reaction force. It's not a action and reaction force. It's different in nature. So see, mg is due to gravitational force. In the earth, due to gravitational force, mg, the earth must be acting in downward direction due to gravitational force. Same phenomena. According to gravitational force, Newton's law of gravitational force, book is also attract in opposite directions, equal and opposite direction. Mg is a downward force, and the book is also attract in equal and opposite magnitude in upward direction mg. Upward directions of mg. This is action and reaction force. This is very important. See, mg is a downward gravitational force according to earth gravity. Book is also acting in upward direction mg. And next one, the table exerts force, normal force on the book. This is n. And now another one, book is also exerted on the table. Another one, normal force. Equal amount of normal force. It is a action and reaction forces. It's important. Mg and n is not a action and reaction forces. Action and reaction force, because of two forces, which means action and reaction force never act on the same body, must be act in two different bodies. That is very important in this region.